Okay, in this problem we're trying to find a parameterization of the intersection of the paraboloid z equals x squared plus y squared with the plane 8x minus 5y plus z minus 9 equals 0. So actually we're trying to solve a system of equations. So I have z equals x squared plus y squared, and this equation here is going to be z equals a 9 minus 8x plus 5y. So I can solve these both for z, and so I can equate these z's. So equating, we get x squared plus y squared equals 9 minus 8x plus 5y. So we eliminated z, and now we want to write this in a standard form. This is going to give us a circle. So I'm going to write this as x squared plus 8x plus y squared minus 5y equals 9. And we need to complete the square on these guys. So I'm going to write this as x squared plus 8x plus, I think half of the 8 is 4 and square, I have 16. And over here I'm going to add 16 to both sides. And then here I'm going to have plus y squared minus 5y. And then I take half of this and square it is 25 over 4. And so over here I'm going to have a 25 over 4. Okay, so these three terms here give us an x plus 4 squared. And then these terms here give us a y minus 5 halves squared. And here this is going to be a 25 plus 25 over 4. It's going to be 125 over 4. And so we have an equation of a circle. And you need to recall that if you have x minus h squared plus y minus k squared equals r squared, the natural parameterization is x is h plus r cosine of t, and y equals k plus r sine of t. And so we do that with this guy here. So I'm going to have, I can write this here that my h is negative 4. My k here is 5 halves. And my r here is square root of 125 over 4, or 5 square root of 5 over 2. So we can write a parameterization now. We have x is negative 4 plus 5 square root of 5 over 2 cosine of t. Y is 5 halves plus 5 square root of 5 over 2 sine of t. And then if we go back up here, z was x squared plus y squared. So I'm going to just have that down here, that my z is going to be negative 4 plus 5 square root of 5 over 2 cosine of t squared plus 5 halves plus 5 square root of 5 over 2 sine of t squared. So this would be my solution. One final point is that I could have used this plane equation here to get z in terms of x and y too if I wanted. So here's my solution, and that's all of it.